Hi, in this video I'm going to do hypothesis test about the difference between two population means when you don't know the population standard deviation. Remember, this is the computer software package problem. I can take a look again one more time and tell you what the problem is. That's the company has a new computer software package developed to reduce the time to produce and to implement information systems and to evaluate the benefits. A sample of 24 analysts is selected. 12 of these analysts are going to evaluate the current technology, the time, and 12 are going to evaluate the time to use the new software package. And then we have a level of significance of 0.05, and then we want to test and want to prove that the new software package takes less time than the new the new software package takes less time than the current. Okay, so remember, we have to come up with the hypothesis. That's the first step. So I'm going to do one more time. I did that before, and I'm going to do one more time here. So the null and alternative we have the current and we have the mean for the new. So I want to prove that the new takes less time, so I have to do this. Okay, this is the alternative. This is the hypothesis. The alternative is the one that I want to prove. I want to prove stuff. I want to do that in the alternative hypothesis. So then in this case, the null is the opposite. I have to assume that the new software takes more time. That's the null hypothesis. So that's the null and alternative hypothesis. Okay, so if I turn this into our traditional way of looking, we have mean of the current, the difference, right? This is the difference between these means. Here is less than 0, and here, I'm sorry, it's the opposite. Here is higher than 0, here is less than 0. Okay, so we know by looking to this one that because this difference has to be positive, it's an upper tail test. Okay, 0 is a positive number, is higher than 0, so it's upper tail test. All right, I know that's upper tail, I know the hypothesis. Now I can go to the data and solve the problem. So using the raw data, this is solving hypothesis tests using the raw data. First step, come up with the hypothesis, understand if it is lower, upper, or two tail, and now you can come here and go to data. Where is my data analysis? Where is my data analysis? Data. I don't have my data analysis here, you see? So I'm going to add the data analysis tool very quickly here. Okay, analysis tool pack. Okay, should be here. Why is it not showing up? Sometimes when it doesn't show up, you have to remove. Let's remove. Let me do that. Add ins. Go. Okay. Let me close. Maybe it's not showing up because I had. Let's see if it now shows up. Data. No. I'm sorry, people. Let me close everything. Don't save. Okay, I'm having problem with the data analysis tool pack. Let's see if now shows up. Data analysis tool pack. There we go. Okay. So I have the data analysis tool here. So you click on data analysis, and then you scroll down, and you see that you have 3 t-tests. We're gonna use the t-test to sample, assuming unequal variances. So for this kind of problem in chapter 10, when we are testing the hypothesis between the difference in two population means, we're going to use this option here, okay? And you click OK, then you select the variable 1 range. It's this, I'm selecting the label. Variable 2 range, I'm selecting the label. So I have to click here, labels. Hypothesized mean difference is always 0, remember that. Alpha 0.05 is according to our problem. Hit OK, and there we go. Now we have the results very quickly. I spent more time figuring out where the data analysis tool was. So here's the degrees of freedom, the means, like we have in the problem, hypothesized mean difference, degrees of freedom, t-statistic, 2.27, the same one we have in our slides, okay? Then you have to ask yourself, is this one tail test or two tail test? Because again, we have one tail and two tail answers, okay? This is a one tail test. The p-value is 0.01. You can reduce the number of decimal places and you can see 0.02. Then you can ask yourself, is this number, let me put here, is this p-value lower than the alpha 0.05? Yes, so I reject the null hypothesis. Okay, and here's the t-critical. Remember we computed the t-critical using Excel. Here's the t-critical, 1.71. So I can have something like this. If the t-stat is higher than t-critical, in this case, because it's an upper tail test. If the t-stat is higher than the t-critical, reject the null. So yes, t-stat is 2.27, which is higher than 1.7 here. So this number is higher than this number. Because it's an upper tail test, it has to be higher in order to reject the null. So I reject the null. Okay, so this is how you solve the problem when you have the raw data, and then you can use the data analysis tool pack in Excel.